Okay, guys, we're going to give this a shot, see if this works. We are in chapter 2. You're in that very last section of your notes on page 1, 2, 3, 4, 5, 6, on page 6. Let's go through our notes here a little bit more. Okay, sorry, let me see if I can get that to work. All right, I hope this works. This is tricky, very tricky. All right, so I told you guys in the previous video that we have all the evidence that we need to support Dr. Jung's claims. Unfortunately, they support all three, and we know that there's only one answer to those claims. So we need to do a little bit more digging. We need more evidence. And this time we're going to test Dr. Jung's claims using these tokens, okay? Each person received a cup of tokens. They look like this, and they're labeled pipe, substance, and fertilizer, okay? So they're going to test the claims by trying to build rust using these atoms. Put those off to the side. All right, so we're going to test the claims using the tokens. We're going to start with claim number 1. You guys can see claim number 1 says the iron pipes changed into rust. So I told the kids, just take the cup that has the iron pipe substance, and I want you to build an extended structure of repeating iron molecules. So I'm going to try and do that here. I'm going to do that right here so you can see my computer and the notes at the same time that you see this. So remember, iron pipes, the iron pipe is just iron. So that is one iron atom, and we have an extended structure, which means that these atoms of iron create molecules, and then those molecules attach or link to each other to create an extended structure. So that's a great example of 6 molecules of iron, and this would be an extended structure. So now, if you remember, we want to create rust, okay? And so I told the kids, go ahead, don't add anything from your other cup. We're only using iron. And try to form the rust by rearranging the iron pipe tokens, okay? So if we're going to have a chemical reaction, we know that the atoms break apart and rearrange to form a new substance. So they're broken apart. Here's the problem. Can I create rust just from my iron tokens? I'm going to let you make that decision, and I want you to write down in your notes. Like I said, document this in your notes. So does your token model support or refute the claim that the iron pipes changed into rust? Go ahead and pause the video and take a minute to document this in that big, let's see if I have it still up. In this section right here in your notes, we're going to do 3 different activities. So you may want to go ahead and draw a line and then discuss that first one. Okay, so I hope you said that this model refutes the claim that iron alone changed into fertilizer. There's no way it can. What are we missing? We're missing the oxygen. So there's no way that that's going to work. So we'll go ahead, put these back in this little cup, and we'll move on. Oops, where's my slideshow? There we go. All right, so I told the kids to reset it, and let's move on. Now we're going to test the claim that the fertilizer changed into rust. So I reminded them what the fertilizer molecule looks like. They've got more than enough tokens in here to create a fertilizer molecule. I need 3 oxygens, okay? And I need 1 nitrogen, and I need 1 sodium. And there's more than that in here, but there's not enough to make another molecule. So, and I did that on purpose. I didn't want them to make more than one molecule, just one. So using this as a guide, we're going to put sodium here, and then oxygen. Nitrogen comes next, and then we have the 2 oxygens on either side. And I want to make sure that these touch because I want to make sure that I am modeling a model or a molecule. All right, so now that I have that, that is 1 molecule of fertilizer. Now I want to try and form rust by rearranging the tokens. So again, I'm trying to model a chemical reaction. And so in a chemical reaction, the atoms break apart, they rearrange to form a new substance. The new substance does have 3 oxygen, right? But what am I missing? I'm gonna let you think about that. And then go to your notes and decide, does the token model support or refute the claim that the fertilizer changed into rust? Go ahead and document your thoughts. Okay, I hope you said that your model refutes the claim that the fertilizer changed into rust. There's no way it can. There's no iron. So that's not going to work. So now what I want the kids to do is keep the fertilizer molecule. So I'm going to rebuild that. Okay, boom and boom. And then I want you to add an iron pipe molecule. So I'm going to go ahead and add molecule is 2 or more atoms. Okay, so there's a good molecule. All right, can you see that? Beautiful. And then the next direction is try to form rust by rearranging the tokens. All right, so I'm going to pretend this is in the sim. We're going to collide these. They're going to break apart. Boom, boom, boom. And I've got my 3 oxygen. Okay. And then I have my 2 iron. Yay. And then these guys are kind of floating around. And guess what I made? I was able to make a rust molecule. So let's test the claim number 3, that the iron pipes and fertilizer changed into rust. Go ahead and document this in your notes. And again, I don't know if I told you guys this, but I'm hoping that you've got some pens or some markers or something, and that you're actually drawing out these models. Especially since you weren't here, it's really important that you don't just have just a sentence that explains it. Especially if you're kinesthetic and visual, you're really going to need to see the colors of the tokens. If you absolutely cannot get a hold of any colors and you have a hard copy, then go ahead and make these atoms circles, but then I want you to create your model like this where you have the atomic symbol inside and you know which one is which. Okay? All right. So my question to you is, were all of the atoms used? And the answer is not in this model. And unfortunately, that's what makes this model have some limitations. Okay, we see evidence that some of the atoms that made up the fertilizer were not part of the rust, and that's okay. This is rust, right? You know how on Monday we had our 2 substances, we put them together, and it appeared that they only made one big globby substance, right? A new substance. But once we actually put it in the sim, we got to see, based on molecular evidence, that there was actually 2 different substances. There was sodium chloride, which is salt, and there was, I can't remember the name of that substance, but it was chalk, okay? So the same kind of thing actually happens here. We have a sodium and we have a nitrogen left over. And in reality, what happens is when sodium and nitrogen bond, they form a substance called sodium nitrate. Now, this is an unbalanced formula. When you get into high school and you get into chemistry, you're going to understand I can't take 2 molecules of iron and 1 molecule of this fertilizer and create 1 molecule of rust. It doesn't work because I have these atoms left over. So we have to have different number of molecules that we put together. We're not going to do that in 7th grade. But it's okay for you to realize I've got those left over, but they wouldn't really be left over. What would happen is we would have enough in order to make this molecule sodium nitrate. Okay? It doesn't work in our model because we don't have 2 extra sodiums in that example. Okay. Hopefully that makes sense to you. Don't get too tripped up on that. So based on our model, which of the claims is possible? And the only answer that you could say would be claim number 3, that both the iron pipe and the fertilizer changed into rust. So what must have happened is the fertilizer got in the water of the well, and then as it sat there and it was passed through the pipes going into the houses of the people who lived there in Westfield, it just sort of had this chemical reaction and it created the rust. The only way to get all of the atoms that you need to build the group that repeats to form rust is to take both tokens out of both of those cups. All right, so we've got key concept number 8. And I think I gave that to you in the first video, but I'm going to go over it again just so that you can kind of relate the key concept to what we've done here. It says during a chemical reaction, all of the atoms that make up the reactants rearrange to form the products. And again, this is not a great example of that. What I'd like to do, and I should have had this keyed up and I forgot to do it, so give me a second to log in. What I want to do is I want to show you an example in the sim, and I'm kind of hoping that you hang on to that remembrance so that you can remember that key concept. We're going to go here into our chemical reactions, and I'm going to add a substance. I'm going to add, what do I want to add? Let's add, I know aluminum. What were you guys working on yesterday? Aluminum and hydrochloride. Let's see what that does. Please let that be a reaction. Yes, beautiful. So what you can see is the number of atoms that we start with are the same number of atoms that we end with. So I'm going to show you the formula here in a second. Okay, so I started out with 1 aluminum over here. There we go. 1 aluminum over here in the reactant, and I have 1 aluminum right there. I started off with 1 hydrogen, and I've got oh, that's a bad example. Can I show you why? Oh, you guys. I thought I would make this easier, and I didn't. Do you see how I'm just saying aluminum plus hydrogen chloride? Maybe this is better. I know. Let's do this. Sorry. This is what we started with. Let's just count them. I've got 1, 2, 3, 4, 5, 6 hydrogens. I've got 6 chlorines, and I've got 2 aluminums. See, this is what I'm talking about. In order to balance your equation, you need to have more than 1 molecule of a certain kind of a 1 so that the ratio kind of evens out. So 2 aluminum, and then 6 hydrogen and 6 chlorine. And when we are finished, right there, I've got 6 hydrogen, 6 chlorine, and 2 aluminum. So boom, it works. Beautiful. Okay? I hope that makes sense to you. All right, let me come back to our last key concept, and then we're finished for the day. Again, key concept number 9 is the law of conservation of matter. During a chemical reaction, Atoms cannot be created or destroyed. Okay? All right, I hope that makes sense for you guys. On Monday, we're going to have the mid-unit assessment, just so I can catch kids who still need some help in certain areas. On Tuesday, we're going to review. And Wednesday is going to be your vocabulary and key concept test. And Thursday will be your Amplify test. All right? Okay, love you much. Talk to you later. Bye.